Alright everyone, in this video I'm going to show you how to build a recommender system using item-based collaborative filtering. Let's get started. Now first of all, why would you want to even use item-based collaborative filtering? Well, it's used to make recommendations based on the similarity between items calculated using people's ratings of those items, and it's based on the idea that people who rate item X highly, like you, also tend to rate item Y highly, and you haven't rated item Y yet, so you should try it. And it beats out user-based filtering because typically there are more users than items, so any items given rating overall is going to be less volatile. Okay? Let's dig into some Python code and see how to actually do this with a movie recommender system. And we're going to start out by first loading the Movie Lens 100K dataset into a pandas data frame. So we have data and item files here. We're just going to load the data into ratings and item into movies, and we're going to actually just merge these guys into one pandas data frame. We're going to call that ratings. So let's take a look at what that looks like, and we're going to build a table of users in the movies that they rated. And look at that. So here you can see we have a user ID. So user ID 1 looks like they rated 101 Dalmatians a 2, 12 Angry Men a 5. They did not rate a whole bunch of other movies. User ID number 2 only rated 3 Ninjas and they gave it a 1. Anyway, so not every user rated every movie, as you can see. You only have a handful of movies per user, if at all. So next, what we're going to do is build a matrix which shows the correlation between users who rated the same pair of movies. And because we want to throw out pairs rated by only a small number of users, we're just going to establish 100 to be the minimum number of pairs of user ratings. Okay, so that's what this code here does. Correlation matrix, and let's look at the head of that. So as you can see, we have the x-axis here of movie titles and the y-axis here of movie titles, and they're cross-correlated. Okay. Now let's take a look at a fictional user 0 who apparently prefers sci-fi. We're going to run this person through our recommender system to see if the recommended movies make sense given this user's preferences. Okay, so we're going to start by establishing a variable for this user's ratings using drop NA to leave only movies for which this user actually left a rating. And after doing that, we can see we have 3 movies here: Empire Strikes Back, Gone with the Wind, and Star Wars. So this person gave the Star Wars movies a 5, but Gone with the Wind a 1. Now let's build our list of recommended movies for this user. Okay, so we are going to loop through each of these ratings, add similar ones for each of them. We're going to retrieve similar movies to the current one that the user rated, scale its similarity by how well user 0 rated this movie, add the score to the list of similarity candidates, group by move, and then once we've looped through those, we're going to say group by the movie title, and then we're going to have to sort by a recommendation score from from highest to lowest. Eliminate movies that have already been rated, and then display the top 10 recommended movies. Okay. So as we're running this code, it's saying, okay, I'm adding the similars for Empire Strikes Back, Gone with the Wind, and then Star Wars. And what we get is this list here. So if we just look from top to bottom, we get Return of the Jedi way up top, which we would expect, right? Since Star Wars and Empire Strikes Back were rated so highly. Raiders of the Lost Ark, well, you know, same director or producer, I believe. George Lucas was involved, right? Along with Steven Spielberg. We got Indiana Jones. And Back to the Future's in there, The Sting. Now, Cinderella, maybe not quite so much, so we're starting to kind of tail off as we go down a bit here, but overall pretty accurate in terms of what we would want to recommend this particular user. Now, what happens if we try increasing the minimum periods in our correlation matrix for 100 to 150? And let's see if that gives us better results. Okay, so here we have min periods 150, and then the rest of the code's the same. And now we're starting to see some different movies pop in here. We've got the same ones up top, but then as we head down, now we've got Star Trek in there. Batman and Jaws, so these might be a little better in terms of recommendations based on those limited number of data points that we had in terms of what this user 0 actually rated. So apparently raising it up to 150 helped. If we go too much beyond that, though, I think what we're going to find is that we just don't have enough movies to cross-correlate to give us useful information. So anyway, that's how to build out a movie recommender system with item-based collaborative filtering. And I hope you got something from this video. Thank you for watching, and we will see you in the next one.